In this video, we're going to take a look at how to work with other bases besides base 10. But let's start with base 10. This is the decimal system that we use, and our place values are all powers of 10, right? 1, 10, 100, 1,000, 10,000, 100,000, a million, 10 million. And the digits we use are 0 through 9. So if we wanted to build the number 743, we'd use 7 of the 100 blocks, 4 10 blocks, and 3 1 blocks. So the other bases work on the same exact system. So if we look at base 9, everything is based around powers of 9. Our first building block is always going to be the same, that's 1. But then instead of going to 10 and 100, it goes to 9, then 9 times 9, 81, then 9 times 9 times 9, 729. So it's going up by a factor of 9 as our building blocks get bigger. And in base 9, we can only use the digits 0 through 8. So that means to build the number 9, for example, we wouldn't use 9 1 blocks. We would use 1 of the 9 block. Base 8, same idea. Starts at 1, then goes up by a factor of 8 as you build your building blocks or your place values. And we can only use the digits 0 through 7, because to make the number 8, we wouldn't use 8 1 blocks. We would use 1 of the 8 block. One more example, or two more examples. Base 7, same idea. The place values go up by a factor of 7. And then base 2 has a special name. I'm skipping over bases 6, 5, 4, and 3 because they all work the same exact way as we've seen. Base 2 has a special name, binary, because you only have two choices, 0 or 1. So bi means 2, like bicycle has 2 wheels. So binary, you only have two choices, 0 or 1. And this is the language that electronics use. So here we start with 1 as our first building block, and then each place value or building block doubles. 1, 2, 4, 8, 16, 32, 64, 128. And we can only use either 1 or 0 of that building block to build a number in base 2. So let's now look at 3 different examples of how we can work with bases. First example, write the number 95 in base 8. So the number 95 in our decimal system in base 8. And below I have the building blocks that we're going to need. Actually, I have a bunch of extra ones, right? Because we don't need to use 512, 4096. All of these blocks we're not going to need to use to build the number 95 in base 8. So you wouldn't want to write all those out. All we need is these 3 blocks, 64, 8, and 1. So first thing to ask is how many 64 blocks can we use? Well, we can only use 1, because if we use 2 64 blocks, it would take us to 128, and we're trying to get to 95. So we can use 1 64 block. And now if we do 95 minus 64, we see that we're 31 away from building the number 95. So we look at our 8 block. How many 8 blocks can we use to fit into 31? Not quite 4, only 3 8 blocks. 3 times 8 is 24. We subtract, we now find out we're 7 away, and we're going to use 7 1 blocks. So the number 95 in base 8 we would write as 137. And that would imply 164, 3 8s, and 1 7. Sorry, and 7 1s. 164, 3 8s, and 7 1s. So that's going from base 10 to a different base. Example 2. We're given a number in a base that's not our base 10 system, and we're going to convert it to base 10. So this one asks, convert this number 101111010 from base 2 to base 10. So let's fill out those 1s and 0s and drop them into their place values in base 2. So that's what we have. And so now we see that we have 128 block. We're not using a 64 block. We're using 1 each of 32, 16, 8, and 2. And we're not using the 4 block or the 1 block. So here we're just gonna add it up. 128 plus 32 plus 16 plus 8 plus 2. Add those up, you get 186. So this number in base 2 is equivalent to 186 in our decimal system. Final example, the trickiest one. Convert 20301 from base 4 to base 7. So here we're going to need to do two steps. We're going to need to first figure out what this number 20301 in base 4 would equal in our decimal system. So let's write out 5 place values in base 4. Goes up by a factor of 4, so we got 1, 4, 16, 64, 256. And now we're going to drop those 5 digits in, 20301. And now we can figure out what this number equals. We have 2 56 blocks, 3 16 blocks, and 1 1 block. So 2 times 256 plus 3 times 16 plus 1 times 1. You add those all up, you get 561. So this number in base 4 is equivalent to 561 in base 10. Second step is now we need to get this number, 561, and drop it into base 7. So I wrote out the first 5 building blocks in base 7, 1, 7, 49, 343, and 2,401. Notice we're not going to need this block right here. It's too big. We can't use any 2,401 blocks to build the number 561. So let's look at the next block over, 343. Well, we can only fit one of those in. 2 of them would take us past 561, so we can only fit one of those in. Now let's subtract 343 from 561 to see how much further we have to go. That gets us 218. Okay, so now we get to the 49 block. How many 49s can we fit into 218? Well, 49 is close to 50. 50 times 4 is 200, so it's going to be 4. And now 4 times 49 is 196. Let's subtract that away from 218. We're getting closer. Now we just have 22 left. So we got to build 22 out of 7s and 1s. So that means we're going to use 3 7s because that equals 21. Now we're just 1 away, and so we use 1 1 block. So we just converted 20301 from base 4 to base 7 with a little stop along the way in base 10.